Please remember that the complete information for the class that you are about to view is at elithecomputerguy.com. Not only do we have our videos there, but we have part lists, diagrams, pictures, and even complete code examples. So if you are watching this video and you want more information, please go to elithecomputerguy.com. Welcome back. As you know, I am Eli the Computer Guy, and in today's class we're going to be doing a project where we're going to be able to track if a vehicle is speeding. So with this particular project, what we're going to do is we're going to be using an Adafruit Ultimate GPS, and when this unit goes over a speed that we specified, what's going to happen is a red LED is going to turn on. So we have a red LED here, basically to tell the user or to tell the driver, hey, you're going too fast. We are going to turn on a red LED, and then beyond that, we are then also going to be logging to an SD card. So to that SD card, we're going to be logging a timestamp. We're going to be logging the latitude, the longitude, and the speed that is above whatever speed that we have input into the system. So for today, the example that I'll be using is 65 miles per hour. So whenever this device goes above 65 miles per hour, the little red LED will turn on and it will start logging to the SD card. So this is a very useful project. Imagine if you have vehicles that your employees use. So you have company vehicles, and you just, as a basic safety measure, you just want to make sure they don't go above a certain speed limit, let's say 70 miles an hour, or possibly 75 miles an hour. This is a way that you can know if your drivers are being too aggressive or they're not driving safely enough. Or imagine if you have a kid, like imagine your beautiful little 16 or 17-year-old kid, you give them a car, and maybe you throw this into the trunk to verify they're not trying to go 90 miles an hour, that type of thing. But that's basically what this project is going to do today. This is a simple tracking project. The important thing about this, though, is it will only track and it will only turn on the LED when somebody goes over the speed limit that you have specified. So there's no huge warning, Will Robinsons today, other than, keep your eyes on the road, don't kill yourself. That would be a bad thing. Other than that, there's nothing really too significantly difficult about this particular project. So again, we're going to be using the Adafruit Ultimate GPS. We've used this in a couple of previous classes. Since we are using this Adafruit Ultimate GPS, what I have found is for some reason, it seems to work best when I'm using an Arduino Uno with Wi-Fi. So for many projects, I use Arduino Unos. When I use an Arduino Uno with the Adafruit Ultimate GPS, for some reason, the latitude is way the hell off. It's always putting me down in North Carolina for some reason. Don't ask me why, but as soon as I start using the Arduino Uno with Wi-Fi, basically all those coordinate problems clear themselves up. I don't have major issues, so that's why we're using the Arduino Uno with Wi-Fi. Since we're using the Arduino Uno with Wi-Fi, that particular board requires that you use ICSP headers if you're going to be writing to an SD card. So whenever you're dealing with an SD data logging module or shield, different boards are going to interact with that shield in different ways. And so for the Arduino Uno with Wi-Fi, it does require the ICSP headers in order to be able to communicate with the shield. So the previous data logging shield that I've used in other classes for things like the Arducam, which I actually like, it simply doesn't have ICSP headers. And so, the shield that I have that allows for an SD card and has ICSP headers happens to be the Ethernet shield. So that's why we're using the Ethernet shield. So basically we have, again, the Adafruit. This is the Ultimate GPS. We have the Arduino Uno with Wi-Fi. We have the Ethernet shield. We have our standard 20x4 I2C screen, and we have our little red LED. This is what's going to be used to create this particular project. So with that, let's go over to the computer. I did a video where earlier I went over the speed limit, so you can see a little LED light go off, and you can see how the information is logged. After that, I will show you how all of this is assembled, and then we will go take a look at the code. Okay, so this is a video of the demonstration that I did a little bit earlier today. So basically I took this unit out into my truck, took it on the highway so I could go above 65 miles per hour. And so when this goes above 65 miles per hour, the red LED will turn on and it will start logging to the SD card. As we can see where I pause this here, it can currently see 6 satellites. My speed when I paused it was 45 miles per hour. The latitude was 39.44, blah, blah degrees. And the longitude was negative 76.82, blah, blah degrees. So basically you can simply plug this in to Google Maps and it will show you where I was when I was doing 45 miles per hour. If we can hit the play button here, basically we can see that the speed is going up and the latitude and longitude is changing. You will notice the longitude here is a little bit off. Every once in a while it will give that bad reading, but we can see the speed is going up. So it's going to 60 miles per hour, it's going to 62 miles per hour. Now it goes above 65 miles an hour. We can see that the red LED is now on and it is now going to be writing to that SD card. And so it's just going to continuously, as the speed is above the 65 miles per hour, it's going to continuously keep that red LED on, and it's going to be sending the values to the SD card. We can go forward a little bit. As I go here, I went below 65 miles per hour, and then you can see that the red LED turned itself off, and when the red LED turned itself off, it is also no longer sending data to the SD card. So again, the important thing here is both the light is on and it's sending information only when you're above 65 miles per hour. So we can go and we can take a look at the file that is created from this. So basically, I simply, within the Arduino sketch, I am printing information to the GPS log.txt file, and we can see that this is what is being printed out to that file. So I went above 65 miles per hour here. So when we're looking at the time, this is GPS time. So where I'm currently at, I do believe GPS time is 5 hours ahead of where I currently am. So when I was doing this, it was earlier in the day. So basically it's saying at 2:49 GPS time or 14:49 GPS time, that's when I went above 65 miles an hour. I was at latitude 39.44 and I was at longitude 76.82. What I can do here, which is kind of cool, is I can simply highlight this. I can simply click and do search Google. So this is simply just built into the text editor. And then I can click on Google and I can see where I then went above 65 miles per hour. So this is the on-ramp. So this is the interstate I was on. I went on the on-ramp. So right there, basically, as I was entering the interstate, that's where you can see I went up to 65 miles per hour. If we go over, we take a look, we can scroll down. We can see the fastest I was going. So at this point, I went 72.91 miles per hour. So I was basically going about 73 miles per hour. I can simply highlight this. I can do a search with Google, and I can see where that was. So I can click on this, and I can see, okay, so that's where I was doing 73 miles per hour. Now, the cool thing is this little GPS, when all the coordinates are right, is actually accurate enough. It shows you which side of the interstate you're on. So basically, this is when I was going out. That's when I went up to 73 miles per hour. If I can go here, I go a little bit later, and let's say when I was coming back, let's say I highlight this, and then what you see is it'll put me on the other side of the interstate. So basically, if I click on here, that's when I was coming back, and you can see here I was on the left side of the interstate. So again, the GPS is relatively accurate, again, especially for a lot of these like tracking projects, not autonomous vehicle projects, but tracking type projects. It's a lot more accurate than you may expect. I will warn you that there are some erroneous readings in here. You will see here, for whatever reason, latitude always seems to be good. It's always in that 39-degree realm. But then longitude, every once in a while, you'll get the 93 degrees pop in. So negative 76, this is where it should be on the longitude. And then every once in a while we get the 93 degrees. This is something to be thinking about if you're going to be putting this into like a production type product. You probably do want to create some kind of filtering mechanism to eliminate those kind of erroneous readings. I did not put in a filtering mechanism simply because I want it easy for you folks to understand how the code works. But again, this is one of those weird problems that might crop up. So that's basically how this project looks in the real world. This is the results that you're going to be getting in the actual log file. So let's go take a look to see how this project was physically built, and then we'll see the code. So here's the basic build for this project. There really is not a lot to it. Again, we're using the Arduino Uno with Wi-Fi board. On top of that, we're using our Ethernet shield. Basically, we have our I2C screen here. So this is our 20 by 4 LCD screen we use for most of our projects. For For here, the VCC, the power is going to be connected to 5 volt, and the ground obviously is going to be connected to ground. The SDA and the SCL pins on here are then going to be going to the SDA and the SCL pins on the Ethernet shield on top. Then we have our Adafruit. This is that ultimate GPS. For this, again, this can be powered off of 3 volts. So we're going to be connecting this to the 3 volt connector for the power. So I'm not going to split it through the breadboard here. We're going to be connecting it to ground. And then for the transmit and the receive, we are going to be connecting these to digital pins 7 and digital pins 8 on the, again, that Ethernet shield. Beyond that, then we do have our little red LED here, standard red LED. We have our standard resistor. This is going to be connected to digital pin 3. So basically when digital pin 3 is turned on, that will then turn the red LED on. And for the ground, we're simply connecting the ground over to the ground on this side of the shield. So this is basically what this particular project looks like. And, you know, as projects go, it's a rather simple wiring job. Now, I did want to show you some of the other data logging shields that are available and explain why I'm not using either of these 2 data logging shields. So again, one of the problems you run into in the Arduino world is there are 1,000 different products that are 99.9% the same, but they're just slightly different. So the big thing with this particular board, why I'm using the Ethernet shield, is it has the ICSP headers. So basically these headers back here, it has the ICSP header connector, and it has the SCL SDA pins that go all the way through. So this is the particular data logging shield that I actually like. So this is a high let go data logging shield. It actually has a real-time clock built into it, and I like this for many projects. The problem is it's smooth on the bottom. It's smooth on the bottom. It doesn't have those ICSP headers. Therefore, this simply does not work with the Arduino Uno with Wi-Fi. So that's why I'm not using this particular data logging shield. This data logging shield I actually specifically bought because it has the ICSP headers, right? See, no ICSP, yes, ICSP. So this actually does have the ICSP headers, but of course, what it does not have is the SCL SDA pins that go all the way through on the bottom. So you can even see here. So with this particular shield that doesn't have the ICSP headers, it does have the SDA SCL that goes all the way through. This one has the ICSP headers, but it doesn't have the SDA SCL pins that go all the way through. So that's why I'm not using either of these, and that's why I'm using this particular Ethernet shield. So if you don't want to use this particular Ethernet shield, again, what you need is you need the SDA SCL pins going all the way through, and you need the ICSP headers, and then you can actually build this project. Welcome to the world of Arduino. With that, let's go over and take a look at the code. So this is the code for the project that we're doing today. I did modify the GPS software serial parsing sketch that is provided in the Adafruit library when you download it. Do remember, whenever you're going to be using the Ultimate GPS, you are most likely going to be using the software serial versions of the sketch. This is something that is not basically called out well enough in the Adafruit documentation. The Adafruit documentation, it tells you to use the echo test or the parsing test. They don't tell you that they have 3 different versions of those tests. And so most likely you're going to be using the software serial versions. They do have an I2C, they do have a hardware serial, but for me I found the software serial versions are the ones that actually worked. So just kind of keep that in mind. That's what we're modifying today. So the first thing that we're going to do is we're going to be including the libraries that are required for the GPS. So we have the Adafruit GPS library and then the software serial library. Then we're going to come down, we're going to configure the LCD screen. So again, it is an I2C LCD screen. So we're going to be including the wire, the LCD, the liquid crystal, as we normally do. We're then going to create the resource for the LCD. So in the future, we're just going to communicate with the LCD, saying LCD begin or LCD print, so on and so forth. And then we're going to be feeding the I2C address. Again, do remember whenever you're dealing with I2C hardware, it is an addressable communication protocol, and so you do have to put the proper address in. If for some reason your screen does not work, it may be because you plugged in the wrong I2C address. Use the I2C scanner sketch that's available available in the examples, make sure that you're plugging in the right I2C address here. Then we're going to come down here and basically we're going to set up the SD card. So we're going to include the SPI library, we're going to include the SD library, and then we're going to define the SD pin. So for the Ethernet shield with the SD card, the digital pin in order to communicate with the SD card is digital pin 4. Now, to be clear, on my other data logging shields, it uses digital pin 10. So this, again, if you're running into a problem where you can't write or you can't read to an SD card, you might be putting in the wrong digital pin here for your shield. So go do a little Google research and see what they have to say. Then what we're going to do here as far as the SD is concerned is we're going to create the file, the variable for file, and we're going to have a variable named log file. So whenever we're going to interact with the file, it's going to be called log file. Then we're going to come down here and basically we're going to be setting up the variables or the requirements for the red LED to turn on. So we're simply going to define red LED to be digital pin 3. And then here, this is where I'm going to set my speed limit, and my speed limit is going to be 65 miles per hour. So if it's above 65 miles per hour, the red LED will turn on, it'll start logging. If it's below, it won't. So you can sit here and you can modify this however you like. To be clear, you can make it really low. So when I was initially doing the code and I was just running around my backyard, I literally set this to 1 mile an hour. So you can set this as low as 1 mile an hour if you just want to run around in your backyard, and it works fine, right? So you can set it to 1 and then go out in your backyard, and when you're walking under 1 mile an hour, the red LED will be on, and then when you start moving a little bit faster, you go to 1 mile an hour, then the red LED will turn on and it will start logging. So when I say 65 miles an hour here, this is kind of like an arbitrary number. I did that just as an example for a vehicle, but you could literally have this at 1 or 2 miles an hour and the project will still completely and utterly work. Past that, we're going to go down here. This is just some of the notes from the original sketch. So GPS goes to power pin. We're actually sending it to power pin 3. So it can be 5 volt or 3 volt. We're actually sending it to the 3 volt. The ground pin, we're going to ground. Transmit is connected to digital pin 8, and receive is connected to digital pin 7. Here's where we actually set up that. So if for some reason you want to modify that, I would highly argue against modifying that unless there's a major reason. But you could modify that there if you wanted to. We go down here, there's some other GPS stuff that we're not going to mess with. The next thing is we're then going to go into the setup routine. So this is the actual setup routine when the Arduino boots up. First thing that we're going to do is we're going to start the LCD screen. LCD, we're going to begin 24. Basically, we're going to turn the backlight on, so on and so forth. We're then going to set the cursor to the first position on the first row, and we are going to simply say Arduino GPS. So this is the splash screen. Write whatever the hell you want to write here. Then what we're going to do here is we're going to use a while loop for if the SD card is not found. So part of this project is that we do want it to be logging. So if there's no SD card, we don't want this device to actually be able to boot up. We do want it to fail. So instead of using an if here, so in other times we used if. So if the SD does not begin, then print something out, give it 2 seconds, and then keep going through the sketch. What we're doing here is a while. So as long as it does not begin, it will just keep printing this out, and you will not be able to go any further. So while, again, exclamation means not begin. So while the SD dot begin at the pin that is connected to the SD pin, so that's digital pin 4. So while that's not able to start, basically set the cursor and say SD card not found. As soon as this is able to start, it will continue through the process. Then we're going to go here. This is basically just a little self-test routine. Make sure the red LED is actually working. So we're going to say pin mode for the red LED. We're going to set that to output. We're then going to digital write to the LED. We're going to turn it on. We're going to delay 1 second. Then we're going to digital write and basically turn the red LED off. That is just simply a way to show us that the red LED is in fact working, making sure it didn't blow out or we didn't screw up with wiring the thing. Then we're going to go through. The rest of this is what's required for the GPS. And again, unless you know what you're doing, do not mess with any of that. Then we're going to go down here. Again, this is more GPS, more GPS, more GPS, more GPS, serial print. So this will print out information on your serial monitor if you need to do some troubleshooting. Then we're going to come down here to the if the GPS fixes. So basically, if the GPS is actually able to grab information. First thing that we're going to do is we're going to create a value for miles per hour. So we're going to create a variable, MPH, for miles per hour. That's going to be a float. Then miles per hour is going to be GPS.speed. So this is actually in knots. Knots, apparently, in order to get miles, is 1.15. Whatever value the knots is, gets you the miles per hour. It seems to work well. So that's going to get us the miles per hour. Again, this is all serial print information out for the serial monitor for troubleshooting. Again, serial monitor. One of the big things, again, remember when you're dealing with the GPS is if you want the coordinates and values you can plug into Google Maps, you want latitude in degrees, right? So latitude and longitude, this gives you the GPS latitude and longitude. This does not work in a lot of the different mapping software you might easily be able to access. Latitude and longitude degrees, in degrees, that is actually something that you can plug into something like Google Maps, and it'll give you information that you care about. It'll actually show you where you are. So they're going to come down here. Again, this is all serial printing out. Not really that worried about. And then here we get to print to the LCD screen. So the first thing that we're going to do is we're going to clear the screen. Then we're going to set the cursor. We're going to say what the speed is. And then basically we're going to say what the miles per hour. So basically what speed we're going. Then we're going to go down to latitude. We're going to spit out the latitude in degrees. Then the next line down is longitude. And we're going to spit out the longitude in degrees. Then what we're going to do is this is where we write to the SD card and we send the alert. So if the miles per hour is greater than whatever the speed limit is, digital write, we're going to turn the red LED to high, and then this is where we're going to start printing information to the SD card. So log file equals SD open, GPS log.txt, we're going to be writing file write to that. We're then going to create a string for the timestamp. So this ugly ass thing right here actually gives us a timestamp. So the GPS day, the GPS month, the GPS year, GPS hour, GPS minute, GPS seconds. Basically, you turn all those values into strings, you concatenate them all together, you add in a couple of commas, you add in a colon here or there, and then you get the timestamp that we're going to be plugging into our log file. Again, feel free to modify the timestamp however you like. The cool thing about this is, again, the GPS is actually grabbing time from the GPS system, so you don't need to deal with an additional real-time clock or anything like that. Just something to think about. So basically, if the miles per hour is above the speed limit, and then if the log file, so you can actually connect to the log file, then it's going to print timestamp, and then whatever the timestamp is, speed, whatever the speed is going to print out in text lat long, and then it's going to give the GPS latitude degrees, comma, then longitude degrees, and it'll spit that out. Else, so basically if the speed is not above the speed limit, the miles per hour is not above the speed limit, it is simply going to turn the red LED to low. And then if we cannot get a fix, so there's a couple of, with these else's, there's a lot of else's here. So with this else here, this goes all the way up to the fix, wherever the fix is. So that actually goes up to here. So basically, if it's not able to fix a location with a GPS, it's going to simply print out that there is no signal for the GPS. Finally, what we're going to do is we're going to print out on the screen the satellites, so how many satellites the GPS is currently seeing, and then it's saying how many that actually is. The int GPS.satellites is how many satellites the GPS unit sees. So this may be a little bit complicated as I try to read it through for you. What I would say is just, again, take a look at this on the main website, take a look at the code before you input it into your Arduino, get an idea of how it works. I think once you read it, it'll make a lot more sense. But this is basically the code that we're dealing with. And again, with this, basically here, all we're doing is this: if the miles per hour is above the speed limit, then we're going to turn the red LED on, and then we're going to print out the information to the log file. If it's not above the speed limit, we're simply going to turn the red LED off. That's basically what we're dealing with here. So there you go. Now you know how to create a little tracking device to verify that the vehicles you are legally authorized to track are actually going under the speed limit that you've defined. Legally authorized to track. Legally authorized to track. Legally authorized to track. I just want to reiterate this so that if you put this into somebody else's vehicle that you're not legally authorized to track, that you don't come back and say, well, Eli told me. Remember, there is what is technically possible, and then there's what is legal. Do what is legal. The two things to keep in mind with this particular project is, one, don't crash your car when you're being all fascinated because the red LED is turned on at 70 miles an hour. And two, don't put this into a vehicle you're not legally authorized to track. Please. it'll be good for all of us. But anyways, this is a relatively simple project. And again, this is one of those kind of cool things where it really starts to show you what you can do now that you have some of these basically variable values. Again, once you can look at the speed that the GPS is providing you, then you can actually trigger events to happen. You can trigger a red LED to turn on. You can trigger for it to start writing to the SD card. Again, something to be thinking about. If you had an LTE or some kind of cellular data modem built onto this, you could actually be sending a real-time alert back to a manager. Again, in this modern world, liability for businesses is a huge thing. If you give one of your employees one of your company vehicles and they start blasting down the road at 85 miles an hour, that can really screw up your profit margin, right? If they hit another vehicle, if something bad happens, that can just make your life a complete mess. So if you had a device like this, again, imagine putting on a little modem or something like that, and it could send in real time and say, hey, your driver is now driving 85 miles an hour, and then you could call them on the phone and say, hey, you're fired, bring back the vehicle, right? Things like that to think about. Or again, simply this can be tracking. You put this into your kid's vehicle. Every few days, you just plug the SD card into your computer. And, you make sure your kid isn't being too stupid. To be clear, your kid's gonna be stupid. Don't expect them not to be stupid, but you want to make sure they're not being too stupid. You know what I'm saying? That's one of the things to be thinking about this type of project, and thinking about how you can use these Arduino devices in the real world. Again, from a personal standpoint, dealing with your kids, that type of thing. From a business standpoint, thinking about how to try to minimize liability for your particular business. I think that's where these GPS units really do become very interesting. So I like this particular project. Again, if you're not going to use this particular project in the real world, just taking this as a base to build something more interesting off of, I think that's a pretty cool thing. So as always, I enjoyed doing this class. Look forward to seeing the next one. If you like the content that I create, please think about going to elithecomputerguy.com and becoming a member or donating. Please understand that all of the educational videos are in front of the paywall. That includes the videos, that includes the notes, the diagrams, and the code example. All of that is freely available and in front of the paywall. But if you want to watch opinion videos, or if you want to be able to comment, you do need to become a member. Membership is $5 a month or $60 a year, and gives you access to those opinion videos and the ability to comment. If you don't want to become a member, you just want to give a one-time donation, there's also a donate button where you can do that. Please understand, in order to provide the education that I am, it does cost money. Servers cost money, equipment costs money, travel costs money. All of these things cost a reasonable amount of money, and the fact of the matter is YouTube's advertising program no longer supports creators the way that it used to. So if you want these classes to continue to stick around and you find them to be valuable, please think about either becoming a monthly member or donating a few dollars for this project.